Lesson 1. Computer, its history. In the modern days, computer is the outcome of sustained technical advancement. In early days, people used stones, pebbles, etc. for counting, and information were recorded through scratches made on walls, pillars, stones, etc. After the invention of computer, more attempts are being made to develop faster devices. Let us study the development of the computer through its various stages. Abacus. The abacus was an early aid for mathematical computations. The word abacus has been derived from the Latin word abax. In 450 BC, abacus was invented by the Chinese. It was also known as counting frame. There are two parts of Chinese abacus. The top of the abacus is known as heaven and the bottom is known as earth. There are 13 vertical rods in the abacus with 7 beads on each rod. A horizontal divider can be found within the frame, so the 7 beads on each wire are separated into 2 beads above the divider, the heaven beads, and 5 beads below the divider, the earth beads. The Chinese, Japanese, Romans, and Russians had arranged these beads differently. Beads can be counted by moving them up or down towards the horizontal divider. If we move beads towards the horizontal divider, it adds that value, but if beads move away, it clears the value. Napier bones. Napier bones, the popular calculating device, was invented by John Napier in 1617. The multiplication was reduced by Napier's bones to a sequence of simple additions. It could also achieve division and square roots. It consists of a wooden box that has 10 rotating cylinders, each of which bears the numbers 0 to 9. There is an inscription inside the lid. The concept of logarithm was given by John Napier, which made it easier to do a variety of arithmetic calculations. He invented the slide rule, wherein logs were used to transform multiplication problems to addition problems. Pascal line. Pascal line was invented by a French mathematician in 1642. It was also known as the adding machine. In order to help his father in his dad's receiving work, Pascal developed the machine. Working on the principle of rotating wheels, the machine was capable of addition and subtraction. Jacquard's loom and punched card. Joseph Marie Jacquard invented the Jacquard's loom in 1801, which changed the weaving industry in the world forever. Jacquard improved the punch card's technology. With this technology in 1840, For the first time, the fabrics with big fancy designs were woven automatically with one man working without assistants. This mechanism was created primarily to help silk industry, but soon it was applied to other industries like cotton, wool, and linen weaving. In his invention of loom, there was a series of connected perforated cards which was passed over needles pressed against the card. Whenever a hole emerged, the needle would activate the threading mechanism by going through the hole. The pattern which was going to be produced on the resulting textile was determined by the pattern of holes. He finished his loom in 1801 and he was called to Paris in 1803, where he was awarded for his loom. Also, he received a pension for lifetime from Napoleon. A boon to the mill owners, Jacquard's technology helped many loom operators lose work. Difference engine. Charles Babbage developed difference engine in 1823 to calculate logarithmic tables. The difference engine comprises a number of columns bearing numbers from 1 to n. Thus, one decimal number in each column could be stored by this machine. In this machine, the value of a column n plus 1 to column n can only be added to produce the new value of n. Analytical engine. Analytical engine is an improved version of difference engine which was developed by Charles Babbage, father of computers, in 1834. Most of the basic features found in a modern computer are found in the design of the analytical engine. There was a memory stored in that machine which was capable of holding 1000 numbers of 50 decimal digits each, 20.7 kb. An arithmetical unit, the mill, was also there to perform all 4 arithmetic operations including comparisons and optionally square roots. The analytical engine was powered by 6 steam engines. There were 2 main parts in it, the store and the mill, because both of these terms are used in the weaving industry. The numbers were held in the store and in the mill where they were woven into new results. The same parts are known as the memory unit (MU) and the central processing unit (CPU) in the modern computer. The key functions of the analytical engine differentiate computers from calculators, that is, conditional statement. Through a conditional statement, a program achieves different results every time when it runs. Taking the conditional statement as a base, one can determine the path of the program, that is, what statements are executed next, which is based upon a condition or situation and is detected at the moment of the running up program. Hollerith's adding machine. This machine was named after a scientist named Hermann Hollerith, 1862-1929. The United States faced a problem in the 1880s which was related to finding a way of completing the national census, since the population had increased almost 20-fold. Hollerith's desk, which consisted of a card reader, sensed the holes in the cards. It was both a gear-driven mechanism using Pascal's mechanism and a large wall of dial indicators to count and display the results of the count. This new method of data gathering and storage was processed within 3 months. It was used for the US Census in 1890. Mark First. At Harvard University, Mark First series of computers was designed by Howard Aiken and Grace Hopper. This series of computers started with the Mark First in 1944. Mark First was an electrometrical computer. By this machine, 2 10-digit numbers could be calculated in 5 seconds. This was the first computer with the purpose of operational general and the first programmable digital computer made in the US. It was not an electronic computer but was constructed out of switches, relays, rotating shafts, and clutches. The 8 feet tall and 51 feet long machine weighed 5 tons and incorporated 500 miles of wire. For long 15 years, Mark First ran successfully. It sounded like a room full of ladies knitting. For logarithms and trigonometric functions, Mark First had special subroutines. It used 23 decimal place numbers, displaying all output on an electric typewriter. If we look at it from today's point of view, Mark First was slow. It required 3 to 5 seconds for a multiplication operation. The ENIAC computer. The ENIAC, Electrical Numerical Integrator and Calculator, was developed by John Mauchly and J. Presper Eckert in 1946. The US military sponsored their research. They required a calculating device for writing artillery firing tables. In 1949, after 6 years of ENIAC, EDVIC, Electronic Discrete Variable Automatic Computer, was developed. It was used at Cambridge University, London. UNIVAC. A milestone in computer, the Universal Automatic Computer, UNIVAC, was invented by Dr. Presper Eckert and Dr. John Mauchly, the same team which invented the ENIAC computer. The UNIVAC had 3 different times: an add time of 120 microseconds, multiply time of 1800 microseconds, and a divide time of 3600 microseconds. Points for review. The first calculating device is abacus. John Napier had invented Napier bones. Pascaline was invented by Blaise Pascal in 1642. Joseph Marie Jacquard invented Jacquard loom in 1801. Difference engine was developed by Charles Babbage in 1823. Analytical engine was developed by Charles Babbage. Charles Babbage is called the father of computers. The Hollerith adding machine was invented by Hermann Hollerith. The Mark I series of computers was designed by Howard Aiken and Grace Hopper at Harvard University. John Mauchly and J. Presper Eckert developed the ENIAC in 1946 and the EDVIC in 1949. A computer milestone named UNIVAC was achieved by Dr. Presper Eckert and Dr. John Mauchly, the team which invented the ENIAC computer.